We are going to talk about hybrid cloud data management. You see it in our tagline. It's something that we've really focused on for the last few years. There's kind of two parts to this. I want to talk a little bit about the evolution of what we've heard from customers over the last few years. What do they want to do? What does this mean to them? And then, kind of to peel apart some of the more advanced things that they've asked us for and how we might be able to solve it. As part of this, Giorgio will show you a preview. We'll actually do a demo of something we call a visual policy builder. And we believe that that's very promising in terms of providing some simple solutions for helping manage more advanced policies. Okay, so happy to take questions along the way, but I'll get started now by talking a little bit about what we mean here, right? So hybrid cloud is one of these topics where, you talk to people about it and you realize a minute later that to them it means one thing and to you it means another. We try to zoom it down on the data, right? So that's what we care about. I'll talk a little bit about the technologies in the next slide because it's relevant to this, but just the conversations that we've had with customers. This really started coming about for us in 2016. We were sponsors at the big cloud shows, like Amazon reInvent for many years, and lots of conversations happen there. They happen with prospects. If you ask these people, what do you want to do? What does hybrid cloud data management mean to you? Well, clearly the basic premise is they have an on-premise, storage repository, and then they see the public cloud, things like Amazon S3 and Azure Blob Storage. But what do they want to do, right? And it starts with the common things like, well, I want to backup. I have on-premises data. I need to protect that. I need to store it for the long term, and I want to put it in a cloud store, right? So that's a common one. Then it gets into the more, sophisticated ones. I want to tier my data based on some rule. Typically, it's my colder, my dormant data. This is under the category of lifecycle management. It does get more complex from there, right? We've heard things like, can you help me move my data to the cloud for burst processing? Might be an analytics service, might be something else. Can you help me migrate? Can you take data from cloud A and put it in cloud B? So that was very common at the beginning. But then the reverse started happening. We started having companies tell us, my data originates in the public cloud. Can you help me bring it back on-prem? Okay, so you can see that there's lots of permutations to this. It quickly became clear that solving it all was pretty hard. There were lots of other advanced examples, move me based on a cost rule, move me based on a location rule, right? Data sovereignty related, metadata value, or something else that has a rule in it. So clearly doing this in kind of a general fashion is a complex problem. Okay, so let me talk a little bit about how we attacked it initially. Okay, and that needs just a quick slide on the product, the solutions that we have in the market to help solve this. Scality's bread and butter flagship product for the last decade has been the Ring. It is software. It's scale-out file and object storage software. As a result of those conversations that we had with all of these customers in 2016, we did introduce a new product. It's an open source product called Zenko. It's available. It's an Apache 2.0 license. It's not a storage solution. It is software for managing data across multi-cloud environments. Okay, so this means that you could use it with multiple public cloud services, or you could use it with on-premises data, whether that's Ring or not. It's actually agnostic from the Ring. Okay. However, we realized that there was such popularity in doing hybrid cloud with Ring that we took that Zenko technology and integrated it directly into the Ring. So Ring itself is hybrid cloud enabled. Okay, so there's those two technology underpinnings. So what did we start with? I think that's kind of the key thing. We really had a lot of discussions. How can we simplify this whole problem? And ultimately, the three kind of common themes we heard were the following, right? Can we provide solutions for taking on-premise data and moving it to a cloud archive, right? We want to put it in a Glacier or something like that for long term. There were plenty of customers that had this idea about taking their active data and putting it in a public cloud service for some kind of bursting usage, processing. I mentioned analytics, but there's many others. And then the one that I think we ended up getting a lot of conversations about and even real production is this third one. This is, can you help me maintain a synchronous or mirrored copy, not synchronous, but mirrored copy of my on-prem data in a public cloud so that in case my on-prem data center becomes inaccessible or has an outage, I have it somewhere else. Okay, so those three kind of ended up being what we focused on as a production deliverable in terms of solutions. Okay, how are those actually delivered in the product? Well, there's a few capabilities. The first is that in order to manage data across multiple locations, you need the concept of a global namespace. You really have to know where your data is, right? That data could be on-prem, both in our product, but more commonly, obviously, there's a huge market of NAS systems. There are other third-party object stores. We made it possible to work with all of those systems. Okay, and then we ended up choosing the most popular public cloud services. You see the list here. So essentially, we provide a way to bridge the namespace across all of those. That means the data, the namespace that we manage actually sees the objects in those other locations. We can also extend metadata on top of that. So you can add system or application defined attributes, and you can search on that independent of the location. You could say, find me all videos that Paul created on Tuesday, and we would return the set of keys that match that. In terms of the actual mobility, the movement or the management of the data, what can we do? One philosophy we had was let's stick within the confines of the Amazon protocol, the S3 API. They have the concept of data replication, cross-region replication, they call it CRR. We made an extension of it to allow it to be one-to-many. So within one source bucket in their parlance, you can have many target buckets. The system will automatically in background manage the actual replication process behind the scenes and ensure that the data arrives. The other one is the lifecycle management API. From an Amazon perspective, this means both expiration, so delete the data based on some rule. In the Amazon world, what is transition? It really means take my data and move it to another storage class. The data might be in Amazon's S3 normal standard protection level. You might want to move it to IA, infrequent accessed, or thereafter Glacier. Okay, we took that concept and extended it to mean move the location of an object. So that means data can move between on-prem and all these various other locations. Okay, so that's the underpinnings of where we started. All right, I wanted to give you kind of just a couple of practical examples for how it actually gets deployed, so you can see, a real-world use of it. This is a biopharma company in the US. They do all this genomics processing, right? So for them, the data is critical. They have huge, massive volumes of it, petabyte scale. They needed a very high performance file system for genomics apps and genomic researchers. They ended up selecting Weka's fast file system as their kind of tier one. Our Ring technology is the data storage behind Weka, both for its live data and snapshots. So you have multi-petabytes living in this on-prem deployment. What was also important for them, though, however, was business continuance. If that site is unavailable, they want to be able to continue. So the solution for that, actually, in this case, was cloud-based DR strategy. They actually had a second data center on the West Coast, and they kind of made an analysis and thought, we can get faster to market. We can have the second site standing up faster if instead we do it in Amazon. And we'll actually save something on the CapEx because we don't have to staff and take care of all the floor space and all the capital equipment. How this works is that we have technology that we run in Amazon. It's referred here as XDM, Extended Data Management. That's actually part of our Zenko technology. And what it's actually doing is being asynchronously notified when new data arrives in the Ring on-prem, and it replicates those objects back to an Amazon S3 bucket. Okay, so in that manner, we keep the Amazon view sort of eventually consistent with what's on-prem. XDM can also manage the failover if the primary site goes away, and the failback once it's been restored. Okay, so this is a production deployment of kind of cloud DR as we talked about. I'll give you one other example, and this is more along the lines of the cloud bursting use case that I talked about. We've seen quite a bit of this in the media industry. So we started working with Bloomberg, who we all recognize, many years ago. And originally, this was purely on-prem. They were just using our Ring technology for media asset storage in their big data centers, both in Europe and in the US. Many applications, both file-based and object-based applications, accessing that storage happily. We started having conversations with them about the cloud. And really what became clear is that obviously their business is all about distributing that content that we store originally in Ring. They wanted to do this in a multi-cloud way. Okay, so they wanted to not be locked into any one of the vendors or services. They also viewed it as very critical to have different services available because they vary in cost They have different capabilities in each various cloud. So ultimately what they did is they deployed Zenko to replicate all of those media assets that are generated daily, because these are daily video broadcasts, simultaneously to multiple cloud regions. Okay, so it's not just the three, it's multiple geographies in each of the clouds. We send hundreds of thousands of video files, fairly sizable ones, up to the cloud. For them, this also had a cost benefit. Before they were able to do this in a multi-replication strategy, what did they do? They took the files that they wanted to first transcode and then content or deliver. They put them all in Amazon. Then they realized, oh, we need it in Azure because there's a video indexer. They would read that out, and that would incur egress charges from Amazon. So there's a really nice side benefit here in having simultaneous transfers in to all the clouds. And then if they don't need it anymore, lifecycle expiration can purge the data and they don't pay the storage footprint. Okay, so those two use cases really kind of exemplify what we've been working on for the last 4 years. And that's really where the customer interest has been. But now we want to talk about the future. Okay, so I want to transition a little bit. So you quickly get conversations about how people can extend these basic capabilities, right? And I have it here on the bullet, but one of the fundamental things we've adhered to so far is to really live within the specification of Amazon's S3 API. Okay, and they have a set of rules that you can define on replication and on lifecycle management. Things like I can filter objects based on a prefix. Okay, and I can do some rules based on some tags. But the questions we were getting were more about exactly what can I do in terms of rules processing, and really ultimately it was, can I insert my own policy rules? Can I insert my own logic? Okay, and that logic might be a function that runs locally, but more interestingly, it might be something running in the cloud. I want to make a decision in a Lambda function, or I want to use a cloud service to do some kind of processing in the rules. Okay, lots of discussions around how can I use metadata. And then obviously, in another session here at Cloud Field Day, we've talked about data sovereignty. Can data sovereignty rules be enforced? Can I use this to figure out where is the data living? And if it's in the wrong place according to some rules, how do I enforce that? Okay, so this is what ended up coming about for us. We've had very practical discussions around that in really 3 areas. Okay, first, healthcare. We've dealt a lot with hospitals from a medical imaging perspective over the last few years. We deal with dozens of hospitals around the globe. We're capturing PACS images and vendor-neutral archive DICOM images. They want to keep those for long-term research, but there's a lot of personally identifiable information on those images. So can they be captured? Can that PIIA be extracted and then put into another repository before the researchers get access to it? And that's an example of a custom data management process. On the edge, autonomous vehicles, we all understand that that's all the rage. Can we capture video images on data in the vehicles? Can we extract geolocation tags and store them as metadata in a storage system? Can we capture video and perhaps do some filtering on it so that not the vast bulk of it is sent through, or perhaps some kind of compression on the sensor data? Okay. The third one, of course, ties in more to the data sovereignty topic. We all know about GDPR. Can we enforce rules for assuring that data lives in the right country or in the right region? These are the kind of things that many, many enterprises are obviously interested in. Okay, so the real question now is, where should this kind of enforcement live, right? And we are a vendor of a data storage solution and a data management solution. We started thinking, does it make sense to have these kind of advanced data management policies in the storage platform? And we do see 3 sort of key advantages, right? One is this whole idea of a single point of truth, a single point of state, right? And that state is both the data storage, because that's what applications are going to store anyway, and all of this metadata and the policies, right? So it would sort of centralize it and thereby decouple applications from having to deal with all of that complexity. It would really be much harder to enforce these policies uniformly if the logic had to be in each app, right? So we see this as a much more scalable solution. We'd like to provide an easy to define interface so that chief data officers and compliance officers can define these. DevOps can implement them in the storage, and then the storage system automates them. right? So that's sort of the keys that we see to making this simpler, more consumable, and ultimately something that companies can leverage better.
Paul, I have a question
Sure.
regarding the idea of applying this at the storage layer as opposed to the application layer. That assumes that the storage layer can understand the context of the data. That's something that an application would natively know. If it's an email app, it knows how to deal with email. If it's a digital image scanning app, it knows how to tag and deal with that. The storage engine underlying that might not have that information. So how do you get that knowledge that the application has down to the storage level?
Yeah, I think you're asking a really good question. I think the answer is it won't apply in all cases because there's always going to be more logic in the app. I think by being able to insert some of the application logic into the storage system, as you'll see, we have the ability to put functions that trigger based on some of these policies. That's part of the answer. The idea of having metadata, descriptive metadata around the objects, object data may be the other. But I think Giorgio may also be able to add some color to that as part of
that's part of what we're going to show. And we see more and more applications who actually use the object store as the state. That's the only state they have. So from there, we can get all the metadata we need from the object itself. But it's not there for every application. But I'm going to show some examples. Maybe it would be easier to follow. So you should see my screen.
And we do.
All good?
Yeah.
Okay, perfect. So this, what I'm going to show today is kind of a preview of things we've been working on. We see more and more of applications that use object storage for the entire state, including some of the critical metadata. And we were trying to think, how can we make this work so that you can set up your policies in one location and have them apply for multiple applications? Because a lot of time people will use the object store to store things like backup, but then use another application to process the data later on. So there's more than one application accessing the same data. So this is the UI of our Zenko product. And for the sake of these demos, I'm actually using a virtual machine, but I've created multiple logical locations. So you see Asia, Europe, USA, and another one, the US as well. You can think of it as the same as Amazon regions. This is the same concept. These are all using my local file system on the VM, but just as a glance, with our product, you can create locations in many different places. So Amazon itself, DigitalOcean, Ceph, Google, Microsoft, even any NFS storage. So if you have an existing file product, you'll be able to see it in our UIs with Zenko. Scality product, of course, and then local file system and different clouds. So the idea is that you would register all of your storage locations so that they become one single namespace for our Zenko and XDM product. Then from that, you can manage them in one location as opposed to having to go to each of the different locations. So what we call workflows is the actions that you can apply to the data automatically in the background. And we support, like Paul said, via AWS nomenclature of APIs. So one of them is CRR, replication, we call it here. Another one is lifecycle. So if I wanted to do a lifecycle, I would take one of my buckets and create a policy to automatically expire object. So I would say, after 5 days, delete this data, for example. So this is using internally for us a workflow engine where the developers have been using that. It's a queuing system that will take an object, send it in a queue, have it processed, take it out of a queue. And we thought, instead of using it for our own need, can we make it available for the user to do its own policies? So we started to think about how to do that. We decided to build some kind of visual policy editor. So I'm just going to create a blank policy. You can have as many policies as you want. They're all active at the same time. And I'm just going to create an empty one. And the idea is it's basically to manipulate metadata of the object and take decision based on either tags, and object speak, or metadata. So I'm going to take as an input to my workflow, I'm going to decide, So this is bucket, it's called demo. I can match all the objects like I'm doing here. I could also do a metadata search into the system and use that as my actual input. And then the idea is to look up the metadata of the object or add metadata. I will talk about that afterwards to make decision on what to do with that object. So for example, I could ask a function. So I will connect this together. And the function, so this is a local local engine we can use. We can also use any AWS function, Azure or Google. So let's say it's a Google Cloud function. I'm just doing something like a demo workflow that's not going to work. But then based on that function may alter my object metadata. So it may add metadata, remove metadata, make some changes. Based on that, I can decide what to do. So if the tag, for example, important has a certain value, let's make it a number, then I can decide to add some kind of tag to this object and update its metadata. So the tag could be, I'm going to leave it like that, but you see the idea. I can also decide this object should never come here because it's not for this kind of object and not store it and call this function that will abort that storage operation. So that's kind of a building blocks. We don't think customers are going to build these blocks from scratch, but it's kind of a tool for data officers or for us to kind of pre-build more intelligence into the system. So this obviously doesn't do much, was more to show the flow. I'm going to take one workflow. So one of the questions is, well, it turns out that objects support metadata, but a lot of applications don't put much metadata. So can we extract metadata and make our own? So this example is very simple. I'm going to take every file from the USA bucket and extract the type from inside the file. So I'm calling a function internally in the system that will extract the metadata type of the object. It's actually looking inside the file to extract the file type. So if I go to, this is a simple browser to be able to see my data. I'm going to upload a file. So let me do the upload. So that's a PDF file. It's going to take a few seconds to run. So I'm going to open a different file that I uploaded earlier, where I see that he added extension JPEG and MIME type image/JPEG. So I was able to extract it from the data. Now I can use it in any of the AWS policy. In my CRR replication, I can say only if it's that tag, image JPEG, and not replicate anything else. This is the file I just put, and he extracted PDF, MIME type, application PDF. So if I were to upload something with a PDF extension, but not a PDF document, it will actually mismatch and show me that it's not the right extension for that file. So now that I've enriched my object with metadata, I can actually use it for any other policies that I want in the system. So if I go back to the workflows, what about if we want to do more than this? What about if we want to know what's in the object? So this one is actually looking at another bucket and calling an external service running in Azure. So it's a service that looks into any image you sent him and extract the features that are part of the image. And so let me just demo that quickly. So I go to that bucket. There's already an image just in case my demo fails. And I'm going to upload something new.
Giorgio, this one's calling the Azure Video Indexer.
Yes, it's calling something. No, it's an image. It's not a video service. It's just for images. So I uploaded this image, which is a cartoon of Scality's cost to serve, and the other one was this simple car picture. So now if I look at the car, I have 13 tags, which tell me the probability of this being a car or tree or sky. you see this metadata, which wasn't there originally, of course. And looking at the cost to serve, it extracted 9 tags, and I know that there's text in it. It's a design and a cartoon. So the storage system had no idea what this was, and now it knows a little bit more, just based on tags. Based on that information, I can actually search or build policies that will only affect data that matches these criteria. So if I go on a search, and text is always sensitive, right? If there's text in an image, it could be personal information. So I can go and do this search that will match every object that has text in it. And so he found my cost to serve video because it was labeled as having text into that video, into that image. Sorry. And I can do any kind of search based on types. There was nothing with color, so you see no answer. But all the metadata is available to search across every location. So even if this was stored on a NAS system using some of our support for NFS, I will also be able to do this metadata search and find out any file that has certain tags on them.
Yeah, can I just quickly ask a question?
Yeah, of course.
What if the system can't read or understand what's in it? So because I'm awkward, I like to break stuff. I don't know what I'm doing. I upload, I don't know, .exe, DLL files, something like that.
Yeah.
What is it going to do? Does the system fall over?
So this is just an example of capabilities, right? I don't know if somebody would run that, but if you were to trust...
I did say that I'm dumb, you see. I do things.
Yeah. So what would happen in that case, if for whatever, you can define it so that if it cannot run the function, it will not store the object. And so we reject the operation. You can have it like that. So you do a put at the object storage level, which auto process it doesn't work, then we fail the put operation with some kind of a 500 error. Or it could be that you want to flag them differently and have them quarantined in some way or send to a bucket for archive or something like that. You could set it up this way.
So those things have to be taken care of, or as policies or something that prevent bad things from happening like that.
Exactly. Yeah. So in that case, I have a little bit of an example of that. If you look at the last one I wanted to demo was more about sovereignty. So I have this all these different locations: Europe, USA, Asia. In that case, I want to make sure that whatever is in the European repository was created in Europe. So we have this function that extracts the region of the object itself when it's being put. So it's basically looking at the client and where the client is coming from to know which region it is based on the IP. This will add a metadata on this object. That metadata, I call it location constraint, could have been called anything. But now I'm saying, make sure that location constraint is Europe. But if it's not, then we're not going to continue processing that data. If it is, then we're going to add a tag to it to say that it's compliant. Okay. So this workflow means, so for the sake of this demo, I'm simulating that I'm from Europe. So, but I'm going to browse, go to this European repository. I'm uploading an object. This one. So I'm going to show the other one that was already there while this is loading. And you see the tags that it's compliant and logged to Europe into my metadata. This one should have been processed too. Yes, same thing, compliant, location Europe. Now, based on this metadata, I can do a lot of operations on the object. I can have a lifecycle policy to delete the data that's not compliant. I can have a lifecycle policy to move it to a different cloud. I can do all kind of manipulation on it. So all these are actually working at the same time. So we know that's something that would be hard to manage from like having a understanding everything that's running into the storage system. So we're trying to find use cases, find specific verticals where this will make sense to package some more intelligence. We're looking into sovereignty. We're looking into hospitals and making sure that PII doesn't exit the system. So if there's anything that looks like a text, don't send that data. somewhere else. There's a lot of ideas. One thing that we've been noticing is metadata becomes more and more important in object. So this is just a list of some object metadata APIs. So you can do search based on prefix. That's the normal search. You can also do metadata search, which is looking into the object metadata across the entire system. You can also do now SQL select, which is a feature where you consider that the object are kind of a database and you do lookups inside of the object. And there's also things like Athena where you actually do that on a much larger scale. So there's a trend so that object system gets more and more states into them. We are adding all that state information and application data. We think that we'll be able to make more intelligent decision and at the right space, because now being in the central state, which is the object storage system, it can apply to every client, every application, and be managed from a central point. That's kind of the idea. And Paul, did I forget anything?
No, you didn't. I think we tried to convey this as kind of the preview. I think one idea we have, of course, is that there would have to be some library of predefined policies that users can build on, because for many people, using even this simplified interface might not be what they want. Yeah. So we think that that's something that perhaps can be done through a community. Okay, so that is really the end of what we wanted to share with you. We'd love any feedback or questions.
I know we were using the graphical interface to create those workflows, but is there an API or a script or language or something or template behind it that you can manipulate without having to use the visual interface?
Yes, absolutely. It's all API based, and the workflow themselves are JSON object, and so you can manipulate them as JSON object.
Gotcha.